So in a second, I'll give you a minute to read it through it. Notice what they're going to do is kind of describe how the sides are related, and then ask us to find the lengths of all three. As you read it through, you might start to think how you could label the sides using some translating. I'll give you a minute to get started on that. So oftentimes they're the same kind of format. Like it'll first say what it's getting ready to describe, like it's getting ready to describe one of the legs of the triangle. When I see the word is, I know I can start translating. One of the legs is. So I want to think about translating 4 millimeters longer than the smaller leg. So it looks like we're referring to the smaller leg. We want to show that the other one is 4 millimeters longer. How would you translate that? Longer sounds like addition. That smaller leg that we don't know, we would call x. So maybe 4 plus x, or maybe x plus 4. And then they go on to describe the hypotenuse a little bit. They say the hypotenuse is, and there's where we want to start our translating, 8 millimeters longer than the smaller leg. So longer still means add. Smaller leg is still called x. On that hypotenuse, the longest side, we want to translate 8 longer than the smaller leg. Sounds good. And then that smaller leg we keep referring to, that's just the x. If you want to ask anything about how we labeled those sides, let me know.
Does it matter where you put like x plus 4, x of the small legs?
No, it doesn't. It can be either one. The hypotenuse is the one that has to be there. The others are interchangeable. So let's think about what goes where in the parentheses.
X, then x plus 4, and then x plus 8 after it equals 9.
That sounds great. And that's really the key to getting it all set up. Now we have an equation to work with. So you can see where we need to do some of that squaring we were warming up with, like x plus 4 times x plus 4. In other words, we want to use FOIL on that. And then over here, x plus 8 times x plus 8. So the next line is going to be pretty long. 1, 2, 3, 4, maybe 4 terms on the left side, and then 3 more terms on the right side. So the little one here, the x squared, I'm just going to drop that down and drop off the parentheses so it looks a little simpler. And then what will the x plus 4 squared make? That'll be
X squared plus 8x plus 16.
Nice. So all 3 of those came from there. And then on the other side, x plus 8 squared. That'll make x squared plus
16x plus 64.
Nice. So you can see that it's quadratic. In other words, we're getting the x squareds in there. So we want to think back to our solving from 6.6 where we need it equal to 0. And we need the other side to be descending. So we just want to clean it up a little bit. I'd like to cancel all of this stuff on the right and move it to the left. Like maybe subtract x squared from both sides. So get rid of that. Subtract 16x from both sides to get rid of that. As I move it over to the left, I'm putting it with the like terms to make this next step a little quicker. So I'm going to subtract all of those to move them over. And that'll leave nothing or 0 on the right like we want. So then I'll go through over here, combine all my like terms. Looks like these will also cancel. So maybe just an x squared minus an 8x minus 48. It was kind of messy there for a minute, but now it's back to more like we're used to. In other words, we're ready to factor, to break it apart and find our two answers. Looks like trial and error factoring since it's a trinomial. We're looking for numbers that add up to -8 and multiply to -48.
-12.
Great. So when we finish that solving, the signs are going to flip. In other words, I'll end up with a +12 and a -4. X still stands for the length of a side, so the negative still doesn't make sense. We'll just keep and focus on the positive. So now that we know x is 12, that'll help us figure out the lengths, like the shorter leg, the longer leg, and the hypotenuse. And that's where we want to remember what we did with the triangle up above. We called the shorter leg x. We called the longer leg x plus 4. And we called the hypotenuse x plus 8. So putting 12 in for all those x's, we'll be able to find our three answers. What we end up with for the shorter leg then, it'll be just the 12. And then for the longer leg, we want 12 plus 4 or 16. And for the hypotenuse, we want 12 plus 8. How about the units on all of these? They'd all be millimeters. These are pretty easy to check also. If we just put them back into the Pythagorean theorem and make sure 12 squared plus 16 squared really does make 20 squared. I know 12 squared is 144. Let's see what 16 squared is. 256. 144 and 256 adds up to 400. And that's what 20 squared makes, so it's looking good. That's a pretty long problem for us. Backing up and thinking it through, is there anything you'd like to double check? That one happened to be trial and error. Could be that other kinds of factoring come up. That could make each one seem a little bit different. But the overall process is the same. Label the sides, use the Pythagorean theorem to write your equation, solve it to fill in your answers.